Okay, so continuing our study of stretches and compressions of the trig functions, today's focus is on the secant function and the cosecant function. I'm going to start with my red pen. Here we have the formulas for secant and cosecant with all of the possible transformations for the parent function. And the following is true for either function. The amplitude is the absolute value of the a term. So that is unchanged regardless of what trig function we're talking about. The period, because these are reciprocals of sine and cosine, go back to 2 pi divided by the absolute value of b. The phase shift continues to be the opposite of c over b. And it also continues to be the largest obstacle or stumbling block. So let me explain. The phase shift is the horizontal action. So what you're doing is you're zeroing out your bx plus c. And you know that we have often in this class zeroed out a horizontal action to solve for x. This is what you're doing. You're taking that quantity that's on the x, setting it equal to 0, and then solving it. So if I were to solve this for x, I would subtract c. You agree? So that's bx equals negative c. Then I would divide by b. And so what that's giving me is a new 0 at negative c over b. So this is pushing your 0 point or shifting your 0 point, the opposite of c over b. So that's where the phase shift comes from. It comes from zeroing out your quantities on your x. Okay? Secant, y equals secant x, has 5 critical points, of which 3 are asymptotes. And y equals cosecant of x has also 5 critical points. Okay? Now, secant is the reciprocal of cosine. And if you recall, back when I taught you about cosine and sine, when I was talking about the cofunctions, cosine is the lead function and sine is the lag function. You remember that? So when you want one full cycle of a cosecant function or a secant function, you want one of those U shapes opening up and one of those U shapes opening down. So what we're doing with your secant function is you're taking the cosine function, starting it at a 0, and then hitting a maximum, hitting a 0, hit a minimum, hit a 0 again. So that happens starting at a cycle at negative pi over 2. Less than, and then your bx plus c, your horizontal actions on the x-axis, and then 3 pi over 2. So that's still a period of 2 pi, but it's going to start at an asymptote at negative pi over 2 instead of at 0. These are asymptotes, these 2 points right here on the ends. And when we're graphing the secant function, the 2 asymptotes on the end have right dead center in the middle of them another asymptote. You're just graphing asymptotes on the zeros of your sine function, cosine function. Okay? For cosecant, your cycle is lagging because it's the reciprocal of sine. So it starts at 0. So it's pi over 2 behind, as you're reading your graph left to right, less than bx plus c, horizontal actions, less than 2 pi. Okay, again, these outer values are your zeros, so they're asymptotes with a 0 dead center between them at pi. So there will be an asymptote at pi. Whereas over here on this one, there'll be an asymptote at the pi over 2. So basically for your secant functions, you're putting asymptotes at the pi's that are divided by 2. And for cosecant, you're putting asymptotes at the pi, and the 2 pi, and the 3 pi, and the 4 pi, like that. Okay? So let's draw one picture of the cosecant or the secant function. I typically, when I draw these, will draw the cosine function first, because if you recall, since they're reciprocal functions, that the cosecant will bounce off of the cosine, or sorry, the secant bounces off the cosine wave. So what I'll do is I'll just come over here to negative pi over 2, and then pi over 2, and pi, and 3 pi over 2. So I'll stretch that cosine function out over a period of 2 pi, and let's hit a 1 and a negative 1 with some room above, maybe a 2 and a negative 2, so that you can see the reflection or the reciprocal function. Okay, remember how cosine starts? At 0, you're at pi, right? So I'm going to go ahead and sketch the cosine function so that I get one peak and one valley. And look, 3 zeros. 1, 2, 3. Definitely want that so that you can get one full cycle of your secant function. All right, so remember that secant is the reciprocal of cosine. Truth? Okay, so at pi, negative pi over 2, cosine is 0. If you flip 0 over, you put 0 on the denominator, that is undefined. There's an asymptote. And over here at 3 pi over 2, just like I told you before, there's an asymptote. And then dead center between them, what the other 0, there's an asymptote. So if I were to just sketch the parent function of the cosine wave, where I can see a 0 hit the maximum, hit the 0, hit the minimum, hit the 0, that will produce one cycle of the reciprocal function. And reciprocal functions of the cosine wave, they're riding the wave. Basically, they're like surfers. So remember they're reciprocals, right? So they flip the curve over. But they approach the asymptotes because they cannot reach the asymptotes. And down here at the bottom of this wave, take that curve and reciprocal, flip it over. And there you see one cycle. And then over here, off to the side, there's going to be another cycle that we're not looking at. And over here, there'll be like another cycle that we're not looking at. But that's what it just continues to repeat the pattern over and over again. So one full U opening up, one full U opening down. Okay, for cosecant, which is a reciprocal of sine, you're starting at 0 and going to 2 pi because that gives you the picture where the cosine or the sine starts at 0 and then does a full cycle up and a full cycle down and then back to 0. So I'll put pi here. 2 pi here. Put your pi over 2's in between. And your 1 and negative 1. And then go ahead and graph your sine function. So starting at 0, 0, pi over 2, 1, pi, 3 pi over 2, negative 1, 2 pi. So you can see your zeros. Just sketch your sine wave. It's always a good place to start. And then get your asymptotes. So I'm going to get my red pen. And at all my zeros, if I write the reciprocal of 0, I get undefined, undefined, and undefined. So your asymptote at 0 and 2 pi, and dead center between them at pi. Excuse me. And then just make reciprocal curves that approach the asymptotes. And there you get one full cycle of the cosecant function. And when you look at them side by side, you can see that secant is pi over 2 ahead of cosecant, right? Because it starts further left. So it's always ahead. It's always hitting a peak first and then hitting a valley first. All the time. Okay, so that's what we're working on today. So we'll do 2 examples on the back of your paper. We're going to do examples C and D. One with a horizontal stretch and one with a vertical compression. So we'll take a look at this. Y equals secant 1/3 x. Identify your A term. What is it? 1. So our amplitude, absolute value of 1 or 1. the b term, 1/3, which helps us to find our period. And in the instructions, if you remember yesterday, I asked you to find the amplitude, the period, the phase shift, and then sketched a graph. So the period of secant is 2 pi, reciprocal of cosine, over the absolute value of your b term. Okay. So keep, change, flip. So instead of doing 2 pi divided by 1/3, we're going to do 2 pi times 3. So that would be 6 pi. So that's a major stretch. So we have to be really thoughtful when we're mapping out our x-axis, how we want to do that. Our c term is 0. So our phase shift, which is c over b, opposite of c over b, well, 0 doesn't really have an opposite. So 0 divided by 1/3 is 0. So no phase shift. Thank goodness. I hate phase shifts. D equals 0. That's the wrong attitude. I love phase shifts. They're challenging. Okay, D is 0 as well. So there's no vertical shift. That's an N. Okay. And then one cycle. And I don't really have a lot of room, so I'll just do the cycle over here in the margin. One cycle of the secant function starts at negative pi over 2, less than, and then you put your bx plus c, so that's 1/3 x, is less than 3 pi over 2. And we're definitely stretching that out by solving for x so that we can see where our asymptotes move to, so that we can find our in-between asymptote pretty easily, and then just sketch a cosine function in those spots. So multiply by 3 to solve for x. So that would be negative 3 pi over 2 is less than x is less than 9 pi over 2. Right? All I'm doing is multiplying by 3 if you're wondering, so that I can clear it, so I can solve for x. Tomorrow in notes, instead of using x, I'm going to use theta. Don't freak out. Don't do it. Okay, so this is one cycle. So that's definitely a stretch right there of 12 pi over 2. 12 pi divided by 2 is 6 pi. So that's a major stretch horizontally, right? Because that's a horizontal stretch times 3. Okay? So I'm thinking how to be thoughtful about how I'm going to stretch this graph. I'm going to get as close to my work over here as I can. All right. So I'm thinking I need like almost 2 pi on the left, and then I need 4.5 pi on the right. Yeah, 9 pi over 2 is 4.5 pi. And then I need negative 1.5 pi over on the left side. So I guess I'll just make this negative pi. I'll make that negative 2 pi. So negative 3 pi over 2 would be here. And that would be negative pi over 2. So a distance of pi, let's see. So that would be pi, 2 pi, 3 pi, 4 pi, 5 pi. And halfway between 4 pi and 5 pi is 9 pi over 2. So there's 9 pi over 2. All day long, I've just been making this really too spread out, and I'm finally making a video, and I squeezed them too close together. Oh, well. Someday I'll get it right. 7 pi over 2. This is pi. Oh, that's not 3 pi over 2. That's 3 pi. This is 2 pi. Okay. So you have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. Pretty big stretch. I'm going to go ahead and finish just labeling these. Give you time to get your graph drawn. amplitude 1. So I'll go ahead and make sure I can go a little above 1 and a little below 1. So I can get my secant function graphed. And then I'm going to use my cycle over here, my one cycle for my asymptotes. So I have an asymptote at negative 3 pi over 2. I have another one over here at 9 pi over 2. And then since it's a secant function, it has another asymptote dead center between them. Would you agree that that should be at positive 3 pi over 2? Right? Because that's a distance of 12 pi over 2s. Cut that in half, 6 pi over 2s. So that's a distance of 3 pi on that side and a distance of 3 pi on that side. Okay, so I'm going to go ahead and sketch cosine function. Starts up high. 0 is where the asymptotes are. In between your asymptotes would be your low point and high point. So here's a sketch of your cosine function. And then what we want to do is get your secant function bouncing off the waves. And then I would just suggest over here on each side of your asymptote, you repeat what's happening. So I went up high, down low, back up high. Over here I'd be down low. Just so you can see a little bit beyond one cycle of the function. And if you do not indicate that on the outside of the asymptote something is still happening, you're graphing over a closed interval, and I have not asked you to do that. So be aware that I'm looking to see a little bit beyond each of your asymptotes, even if it's just a little tiny curve with an arrow on it. Questions? Okay. All right, then, let's finish this up. Here we have y equals 1/4 cosecant x, reciprocal of sine. So our A term is 1/4. So that means that our unit circle now has a radius of 1/4. So our amplitude is definitely crushed down to the absolute value of 1/4, which is 1/4. Your B term is 1. So that means your period is not changed. So that's 2 pi divided by the absolute value of 1, or 2 pi. That's nice. It's always nice when you don't have to do a period change or a phase shift. Your C term is 0. And your phase shift then, 0 over 1, which is 0. D term is also 0. So no vertical shift indicated. And then one cycle. I can spell the word cycle. Remember where cosine starts? Sine starts. A period of 0, less than or equal to bx plus c. So that's x not equal to, because that's an asymptote. So you approach to 2 pi. And because there's no period shift and there's no bx plus c, we're not adjusting that at all. So be thoughtful about your graph. Remember that I want to see a little bit to the left of a cycle and a little bit to the right of a cycle. So I'll have a little bit to the left of 0, and I'll go to the right of 0. So maybe I'll put 2 pi here, 3 pi out here. Cut those values in half. Amplitude 1, which is going to be crushed down to 1/4. -1 crushed down to -1/4. There we go. So again, we're just going to start one sine function so that we can reflect off of it. So we'll start at 0, 0, pi over 2, 1/4, pi 0, 3 pi over 2, -1/4, 2 pi 0, 5 pi over 2 up, and then 3 pi 0. And then over here, I'll just hit the negative. So we have this little sine function. And then we'll hit asymptotes at all the zeros. So at all of the intervals of pi, are all of the pi integers times pi. And then let's see, we'll just bounce off the peaks and valleys. Draw a little sketch. There's your cycle from 0 to 2 pi. And then I got another half cycle going on over here. And there you go. Maybe a little there. And there's an example of an amplitude change with your cosecant function. Okay. So on Canvas, there is an assignment that is labeled 9.2 assignment. And before I change the page, I just want to make sure that while you guys are all finished, does anybody need this page a little longer? Okay. So I'm going to go ahead and just press. Okay, so your assignment is on Canvas. You're doing problems 2, 3, 6, 7, 14, 22, 32, and 44. It'll be 2 of each type of graph, 1 vertical change, 1 horizontal change of each. So just a little bit of practice. And be prepared. Tomorrow, what we're going to be doing is doing a double compression or a double stretch. So we'll have a vertical and a horizontal together. And then on Friday, some phase shifts. So prepare yourself.